And that would be our answer for part A, finding the equation of the potential at a point P on the axis. Then we're going to extend this, and we're going to find the electric field using this potential equation. So our E is going to be negative del V and we're going to use Cartesian coordinates for this because we have an x coordinate here. So negative, open operator, partial x I plus partial y j plus partial z k, operating on 1 over 4 pi epsilon naught q over square root x squared plus a squared. So we pause here for a second, and we notice that there are no y terms, and there are no z terms. So those derivatives are both going to go to 0, and then we just need to find the derivative with respect to x. So our electric field is going to be equal to negative partial x 1 over 4 pi epsilon naught q over square root x squared plus a squared in the I direction. So the 1 over 4 pi epsilon naught and q and this negative sign are all going to get factored out in front here. So we're going to have negative big Q over 4 pi epsilon 0 partial x, and I'm going to rewrite this now, x squared plus a squared, whole thing raised to the negative, because it's in the denominator, 1/2, because it's a square root power. Now we're going to find the derivative of this term using a chain rule, and we're just going to carry our constants along. So I need more space. I'm going to go to a fresh page and rewrite those terms. So all I've done so far is just copy over from the previous page. Now we're going to find the partial derivative with respect to x of this term. So we're going to use a chain rule here. All of our constants come along for the ride. 4 pi epsilon 0. And our unit vector comes along for the ride. The derivative of the inside is 2x. The derivative of the outside would be negative 1/2 x squared plus a squared to the negative 3/2, close big paren. Now we can combine some like terms here. The two negative signs become a positive sign. The 2 cancels with the 1/2. And we rewrite this as q, remember the negative sign's gone, times x over 4 pi epsilon 0 x squared plus a squared, whole thing raised to the 3/2 power in the I direction, which now gives us back the same result that we got from Coulomb's law, indicating that we have done this correctly and also indicating that our fundamental principle is correct.